Good morning, Orandal. Myself, Dr. Balaji Maram, Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana. Today, we will discuss about the concept OSM model and TCP/IP protocol suite. This earlier also we have discussed about some of the topics from computer network subject. Uh, the ISO, it is a reference model. In reality, it is not a uh, it is not available in the reality, means in real technical world. But parallelly, one more model is available in today's market, that is TCP/IP protocol suite. Uh, but actually, here OSI reference model, it gives some idea about how the data is moving from source to destination. It is like virtual, but the reality is the TCP/IP, and it explains how a data is moving from source to destination through different types of layers. Communication architecture. Here it is a strategy for connecting host computers and other communicating equipment. Is here we need to discuss what is the logic behind the data is moving from source to destination, and what type of means addresses are required, what type of means hardware components are required, what is the strategy, what is the logic, and how to move from one step to another step, those things. And second point, device and necessary elements for data communication between devices. Means each and every layer has its own style, and each and every layer has its own logic to handle that particular data. Means there is no change in the data, but they will add some additional information to the data only. It okay? Here, miss, suppose a layer 1 and a layer 2, they are handling that same data in different styles. Because different tasks have been assigned to each and every layer. The third one, a communication architecture defines a standard for communicating host. So here, a standard format plays a vital role. Means, whether it could be in college, or whether it could be a university, or any organization or any company, whatever it may be. That is the reason usually we are following means ISO certifications, those things. So similarly, for network communication also, definitely we can find different types of protocols. When different protocols are there, we need to standardize the formats. Then only the communication is possible, and it is like uniform in the entire world. Otherwise, the communication will not be happened, and when it is different from country to country. That is the reason some standard formats are required. Then a programmer formats data in a manner defined by the communication architecture and passes it on to the communication software. So when the protocols are standard, the formats are standard, definitely the programmer easily can write the program, and easily the data is moving from source to destination. Next, separating communication functions adds flexibility. For example, we do not need to modify the entire host software to include more communication devices. So here it is also very important. Suppose our laptop is there, our desktop is there. When we change some of the devices, it will not affect the entire program. Means the program should be in a position to adapt different types of devices dynamically. Means dynamically we can add the printer, or we can add some webcam and so on, and dynamically we can detach or change the device. So in any case, it should be in a position to adapt such changes. And layer architecture simplifies the network design, because when we design for data communication, and the design is very lengthy, then it will create so many confusions. Means here, suppose when there is a means a project, the entire project is a single program. Means definitely it is very difficult to maintain that single program. This single program may contain some 1 lakh lines. That is the reason. First of all, we are dividing the project into a modules, and modules can be divided into different types of programs and so on. So when program length is simple, automatically means it enables the users or programmers to find the bug and to rectify the bug easily. Because when there is a program, the program may contain some 500 lines. Definitely, easily we can find the bug and rectify the bug. That is the reason when there is a problem, that is like data communication between source and destination. So in such scenario, we should not design the entire thing in a single component. Definitely, it should be divided into different parts. Those parts are nothing but layers. So that layer architecture simplifies the network design, and it is easy to debug network applications in a layered architecture network. Suppose when there is a problem in some layer, so we should take care about that particular layer only, that specific layer only. We should not check all the layers, because suppose the upper layers or lower layers, when those layers are working properly, why we need to check unnecessarily? So wherever bug is there, we need to check what is the bug in that particular layer only. Next, the network management is easier due to the layer architecture. Next, network layers follow a set of rules called protocol. So here protocol. Every time we are calling like file transfer protocol, HTTP, SMTP, what is that? SNMP. Okay, uh, those are the different types of protocols. Here the question is, what is a protocol? The protocol is nothing but some set of rules and regulations only. Okay, means when some manufacturing companies are there, those manufacturing companies or those software means companies, definitely they need to check these protocols only. Means what are the rules and regulations for implementing FTP, SMTP, SNMP, HTTP, those things. Accordingly, they need to write the software code or hardware code, whatever it may be. Okay. Here, the protocol defines the format of the data being exchanged and the control and the timing for handshake between the layers. Later, we will discuss about the handshake and so on. So here, Open Systems Interconnection OSA model. Already I told here, ISO OSA is established in a committee, that is 1997, to develop an architecture for the communication. And here it is like a reference model, in 1984, the OSA reference model was approved as an international standard for communications architecture. Okay, this is the picture of OSI, and here OSA reference model. Reference model now considered as the primary architectural model for intercomputer communication. Okay. Here, OSM model describes how information or data makes its way from application programs through a network medium to another application program located on another network. Definitely, it is one type of reference model only, and it tells each and everything about the data communication between source and the destination, and how the application should take the data from the user, and how the data is moving from one layer to another, and what are the roles and responsibilities of each and every layer, and how the data is changing from layer to layer. These things are defined in OSA model. And here, the OSA reference model divides the problem into moving information between computers over a network medium into seven smaller and more manageable problems. This separation into a small, more manageable functions is known as layering. These are the layers, OSI layer. So here, just you can check from bottom to top: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay. So here the upper four layers are belongs to host layer. Those are called host layers. The lower one are called media layers. Means those are like hardware components. Okay. The process of breaking up the functions or tasks of network into layers reduces the complexity. So definitely, when there is a single program and a single program is divided into multiple parts, which one is best one? Definitely, the second one is the best one. The single program should be divided to smaller parts. Here also same. When it is divided into a layers and it reduces the complexity. And each layer provides a service to the layer above it in the protocol specification. Each layer provides a service. Means each layer provides its own service to the lower layers, to the upper layers. Okay, in center side, it gives services to the lower levels, lower layers, and in receiver side, it gives the services to the upper layers. Okay, so here each layer communicates with the same layer software or hardware on the other components. Definitely, each layer means suppose here network layer means in the destination also network layer. Here it is a data link layer means in destination also data link layer. So here application layer will discuss with application layer in the destination. The lower four layers, transport layer, network layer, data link layer, and physical layer are connected with the flow of data from end to end through the network. Means that is like end to end communication. But the upper four layers, application layer, presentation layer, and session layers, means three layers, are oriented more towards services to the applications. These are related to services. The remaining are related to end-to-end communication. Okay, it is not bothering about remaining thing, just end-to-end communication. The data is encapsulated with necessary protocol information as it moves as it moves down the layers before network transit. First of all, we will discuss about physical layer. The physical layer provides physical interface for transmission of information, and it defines rules by which bits are passed from one system to another on a physical communication medium. And it covers all mechanical, electrical, functional, and procedural aspects for physical communication. So here, physical layer, it is responsible for moving data from source to destination in the form of bits, bits, bytes, those things. Because it don't know about a meaning, but it in the form of signals, analog signals, digital signals, it moves the data from source to destination in the form of bits 0 and 1s. Okay, so here it provides a physical interface for transmission of information. It provides some interface, and it defines rules by which bits are passing from one system to another, which based on its own functionality. It generates some set of rules and regulations. According to those rules and regulations, the bits are moving from source to destination. Okay, and here it covers all mechanical, electrical, functional, procedural aspects for physical communication. Already I told the data is moving from source to destination in the form of bits 0 and 1. Uh, and with the help of the signals like analog signals and digital signals. And such characteristics as voltage levels, timing of voltage changes, physical data rates, maximum transmission distances, physical conductors, and other similar attributes are defined by the physical layer specification only. So here, already I told, the data is moving from source to destination in the form of voltage only. So it should take care about voltage levels, timing of voltage changes, physical data rates, maximum transmission distances, and so on. Its data link layer attempts to provide reliable communication over the physical layer. Means in physical layer, it is taking care about the data is moving from source to destination in the form of signals only, but signals means those are physical signals, those are not virtual. That is the reality. So in such scenario, because of some voltage drop or some other because of various factors, the data may be right or wrong in the destination side. So in such scenario, the data link layer should take care about the reliable communication over the physical interface. That is the reason the entire data will be divided into frames and reassemble those frames in the destination side. So this is the main responsibility of the data link layer, and also it creates and detect frame boundaries. Okay, and after that it handles errors by implementing an acknowledgement and retransmission scheme. Also, it takes the responsibility to handle errors, okay, and implementing acknowledgement service and retransmission scheme also. Means many times we can find when the source sends 100 packets, the receiver may receive 90 packets only. What about remaining 10 packets? Those remaining 10 packets are dropped because of missing those packets. Definitely, there is a facility that is a retransmission scheme, and it supports point to point as well as broadcast communication. Okay, this is like point to point communication, means node to node communication as well as broadcast communication. Suppose when there is a LAN in the LAN, it gives node to node communication as well as broadcast communication. Also, it supports simplex, half-duplex, and full-duplex communications. So here, uh, what about simplex? Simplex means that is like one-way communication, one-way, strictly one-way communication. Maybe like A to B means the communication is possible in A to B only. That is simplest communication. What about second one? Half-duplex. Half-duplex means when there is a necessity the communication from A to B, the communication will be happened from A to B. But after that, BTA communication is necessary. Every BTA communication is necessary. But at any time, is one-way communication is possible, either A to B or B to A. Next one, full duplex communication. Full duplex means at a time both communications may possible. Okay, means A to B, B to A. Such communication is possible parallelly. Okay, that is called full duplex communication. Here, the sublayers in data link layer. Here, total two layers are there: media access control and logical link control. Media access control. The data link layer functionality is usually split it into logical sublayers. The upper sublayer termed as LLC that interacts with the network layer above, and the lower sublayer termed as MAC, media access control, that interacts with the physical layer below. Okay, this is the overall picture. Means LLC is able to handle upper layers of DLL, and MAC is able to handle the lower layer, that is physical layer. Okay, so here LLC is responsible for handling multiple layer 3 protocols, that is like multiplexing and demultiplexing, and the link services like reliability, flow control. Okay, these are the main responsibility of Mac. Okay. uh, no, Miss responsible for LLC. Now Mac. Mac is responsible for framing and media access control for broadcast media. So here LLC, logical link control, is responsible for multiplexing and demultiplexing link services like reliability and flow control. But whereas Mac is responsible for framing, already I told, when there is a data, the data is divided into different parts. Those parts are called frames. Means for every frame there is a need to insert one frame boundary. Okay, means starting of the frame, end of the frame, then only it is easy to recognize this particular part is one frame. Okay. Next one, network layer. So here it implements routing of frames. Means those are called packets in network layer. Through the network, defines the most optimum path the packet should take from source to destination. So here, when there is a network, means suppose LAN is there, MAN is there, or some other network is there. In such scenario, when we find the route between source and destination, we can find different paths. But here the question is which path is minimum? Means which path is has shortest distance? Okay. Uh, it defines logical addressing so that any endpoint can be identified. Okay, just a minute. Okay, defines the logical addressing so that any endpoint can be identified. So here, logical address, physical address, two different addresses are there. Here, the physical address means that is highly confidential. That is the reason the network layer creates some means logical addresses. Those are visible to the user, but the physical addresses are visible to the means hardware components only. And it also handles the congestion in the network. Definitely, congestion plays a vital role. Because of congestion only, you can find so many packets will be dropped. So that is the reason it should take care about the congestion and facilitates interconnection between heterogeneous network, facilitates interconnection between heterogeneous networks. Uh, means, that like internet networking. The network layer also defines how to fragment a packet into smaller packets to accommodate different media. Definitely, here so many limitations are there for the communication cable. So that is the reason there is a need to find MTU, maximum transmission unit, based on maximum transmission unit or capacity of the communication channel. The network layer defines how to fragment a packet into smaller packets. Next one is transport layer. The purpose of this layer is to provide reliable mechanism for the exchange of data between two processes in different computers. Two process, okay, two systems are different, two processes are different. Here, the communication between two processes ensure that the data units are delivered error free, ensures that the data units are delivered in sequence, ensures that there is no loss or duplication of data units, provides connectionless and connection-oriented services, provides for the connection management, and multiple connections over a single channel. Single channel means single communication channel, but here logically you can find so many connections. So here the transport layer means it is the communication between process to process, and it ensures that the data are delivered error free. Means there should not be any error, and all data units should be delivered in a sequence, and all data units should be unique. There should not be any duplicate, and it provides a connection oriented communication and a connectionless communication, and provides for connection management and multiple connections means when there is a single physical communication channel, definitely we need to divide the single physical communication channel into logical communication channels. You know, okay? Then only we can transmit more and more data. Otherwise, it is not at all possible. Next one, session layer. Session layer provides mechanism for controlling the dialogue. Dialogue means that is like one type of session between the two end systems. It defines how to start, how to control, and end conversations between the applications. Okay, here you can find different types of applications. For any application, definitely there is a need of one session. Okay, in that session only the communication is possible. The session time duration is like 5 minutes, 10 minutes, it depends. And here, one best example, when you are accessing the IRCTC website, definitely we will get a 10 minutes time only. That 10 minutes time is nothing but session. Okay, after expiry of 10 minutes, your session will be closed. Means the communication is not possible. Again, you need to reconnect. So that is nothing but a session. So for any communication, definitely there is a need of a session. When there is a session exists, then only the communication is possible. Okay. This layer requests for a logical connection to be established on an end user's request. Okay. Any necessary login or password validation is also handled by this layer only, and the session layer is also responsible for terminating the connection. This layer provides services like dialogue discipline, which can be full duplex or half duplex. Session layer can also provide checkpoint mechanisms such that if a failure of some sort of occurs between checkpoints, all data can be retransmitted from the last checkpoint. Okay, checkpoints. Which checkpoints you might have observed in DBMS? Okay, we will discuss. So here, this layer requests for a logical connection to be established between sender and receiver. That logical connection is nothing but one session. Any necessary login or password validation is also handled by this layer. And suppose for that session, usually we are giving credentials, and checking those credentials is also handled by the session layer only, and it is also responsible for terminating the connection, establishing the connection, terminating the connection. Everything is under the control of session layer only, and this layer provides services like dialogue discipline, full duplex, half duplex. Those things will be happened under session layer only, and it is also provides one more additional advantage, that is checkpoint means suppose when communication is going on, 100 packets are there. First of all, 10 packets have been sent successfully, then checkpoint will be there. Then 20, 30, 40, 50, like that. So everywhere it simply puts some checkpoint. Suppose if any failure occurs means it checks up to which checkpoint the communication is perfect. After that, it starts retransmission the packets. So all these things comes under this session layer only. Next, presentation layer. So here, cryptography concepts plays a vital role because it gives more security to our data, and it takes care about the compression, also compression. Okay, the presentation layer defines the format in which data to be exchanged between the two communication entities, because different applications giving data in different formats, but the presentation layer will not accept different packets. That is the thing. That is the main reason the presentation layer takes care about the standard format. This every means data format is converted to some standard format at the presentation layer only, and it also handles data means compression and data encryption also. Means here languages can be different can be different of two communication systems. And the communication plays a role of like translator. Okay, it is like a translator because it takes care about the standard format. That is the reason It also acts as a translator between different formats, and it performs data compression, data encryption, conversion, etc. Next, application layer. Application layer interacts with the application programs and is the highest level of OSM model. Application layer contains management functions to support distributed applications. Examples of application layer are applications such as file transfer, electronic mail, remote login, etc. Okay, these are function application layer. So here, OSI in action. A message begins at the top application layer and moves down to OSI layers to the bottom physical layer. Okay, just already we have discussed. Our user data will be handled by the application layer. Then it will go to presentation layer, then it moves to session layer and will be handled by the transport layer, then go to network layer, then it reaches data link layer and will be handled by the last layer physical layer, and it transfer the data from source system to destination system. Okay, so here you can also check in the diagram. The diagram is like when it reaches the transport layer, TCP header will be added, and after that IP header will be added. After that LLC header will be added. After that MAC header will be added. Then some Taylor part also will be added. But finally, in physical layer, it handles the entire data in the form of bits only. Okay, as the message descends, each successive OSM model layer adds a header to it. Already you have observed in the figure, and a header is a layer specific information that basically explains what functions the layer carried out. Okay, and at the receiving end, the headers are stripped from the message as it travels upward to the corresponding layers. Okay, this is the overall picture how a packet is moving from application layer to physical layer in source side and physical layer to application layer in the destination side. Here, what are the merits of OSA reference model? Okay, merits. The OSM model distinguishes well between services, interfaces, and protocol. Everything is good because everything is virtual only in OSM model. It simply distinguishes different types of services, different types of interfaces, different types of protocols. Okay, the protocols of OSM model are very well hidden. Okay, protocols can be replaced by new protocols as the technology changes because protocols are like independent, which they does not depend on the entire architecture. Okay, and supports connection oriented service and connection less service. What are the demerits? Okay, model was devised before the invention of protocols. Okay, actually, theory and practical entirely different. When we talk about practical, during the practicals we may face different types of problems. Right, okay, so in such scenario, there is a need to modify the theory because of the reality. So here also the same thing is happening. Model was devised before the invention of the protocols. Second one, fitting of protocols is a tedious task. Okay, means means like defining or adjusting those protocols is very difficult. It is just used as a reference model. For reference model, it is okay, but reality it is very difficult to implement all the concepts which were explained in 7 layers. Okay. Now, in today's market, this is the overall picture. The left side was a reference model, in right side TCP IP reference model, and the comparison also you can check. Okay, in left side you can check left side or right side. Right side also same thing. Application layer, presentation layer, session layer are combined into a single layer, that is application layer only. Application layer, and transport layer as it is, network layer as it is. Then last two also combined into single, that is network interface. Total four layers are there in TCP/IP model. And here, according to picture, the left seven layers are related to ISO OSA reference model. Those are like virtual. But what about reality? Reality is TCP/IP protocol suite. In TCP/IP protocol suite, you can find four layers only: application layer, transport layer, network layer, network interface layer. These are four different layers. The Internet Protocol suite, known as TCP/IP, is a set of communication protocols used for Internet and other similar networks. It is named for two most important protocols in it, that is TCP, Transmission Control Protocol, and Internet Protocol, which were the first two networking protocols defined in this standard. Okay. These are the different of applications, protocols, or services available in TCP/IP protocol suite related to application layer, Telnet, FTP, SMTP, POP3, SNMP, NNTP, DNS, NIS, NFS, HTTP, and so on. These are the different types of protocols are available at application layer only. Next, transport layer. Application layer in TCP/IP. Transport layer means that is like and means what is that? Process to process communication. That is two protocols are there: UDP and TCP. Next one, internet layer, IP, ICMP, ARP, RARP. Okay. Uh, These are different protocols defined in that layer: IP, ICMP, ARP, RARP, etc. Next, the link layer, FDDI, Ethernet, ISDN, X.25, some other thing. You can check it. That is link layer. Next here, TCP/IP stack, protocol stack. These are the network connections. We suppose when the data is moving from one system to another, means from here to some other country, some Australia. So here, host A is in India, host B in Australia. But how it is moving from host A to host B? Definitely, it is possible through different routers only. Through routers, the data is moving from source to destination. So here, this is the picture. You can check application layer, then transport layer, then internet, then link layer. Internet, then link layer. Link layer means Ethernet, or fiber optic cable or satellite, whatever it may be. These are some intermediate routers. Then finally, it reaches the destination. Then TCP/IP encapsulation. Okay, so here, first one, data. Second one, UDP and UDP header. Next one, the previous data and IP header. The last one, the previous data, frame header, frame footer. Okay. Here, network access and a physical layer. The TCP/IP reference model does not discuss these layers too much. The node should connect to the network with a protocol such that it can send IP packets. This protocol is not defined by TCP/IP, mostly in hardware. It is known as Ethernet. Okay, so here Ethernet, that is related to the last layer, that is network, means that is like physical layer. So here, internet layer pack data into data packets known as IP datagrams. These are called IP datagrams, which contain source and destination addresses, information that is used to forward the datagrams between host and across networks. The Internet Protocol is also responsible for routing of IP datagrams. Okay, packet switching network depends upon connectionless inter-network layer. Its job is to allow host to insert packets into any network. The main protocols included at the internet layer are IP, ICMP, ARP, RARP, IGMP, and some other protocols also there. You can remember at least these four protocols. Okay. Next, IP addressing. The IP addressing conventions are part of IP protocol. Designing an IP4 addressing scheme introduces IP4 addressing, and IPv6 addressing audio introduces IPv6 addressing. So here, host-to-host communication, IP determines the path a packet must take based on the receiving system's IP address. And packet formatting. IP assembles packets into units that are known as datagrams. Datagrams are fully described in internet layer where packets are prepared for delivery. Next, fragmentation. If a packet is too large for transmission over the network media, IP on sending the system breaks the packet into small fragments, and IP on the receiving system then construct the fragments into the original packet. So here, transport layer. Uh, transport layer means this is for end-to-end communication only. Two protocols are there, TCP and IP. So here, TCP, just a minute. Okay. So here, TCP, it is connection-oriented protocol. Means before going to exchange the data between source and destination, definitely there is a need to establish a connection between source and destination. Okay. Uh, Next, stream of bytes service. Sends and receives stream of bytes, not messages. Okay, it is like stream. Next, reliable in order delivery. Means there is a 100% reliability, and the order should be in a sequential manner. Okay, and here checksums to detect corrupted the data. Here checksums are very useful to identify the errors in the data. Next, acknowledgement facility is there. Retransmission is facility is there for reliable delivery. Sequence numbers to detect losses and reorder the data. Okay. Next one, flow control. Present overflow of the receiver's buffer space. Next, congestion control. Adapt to network congestion for the greater good. Just a minute. Next, checksum to detect corrupted data. Acknowledgements are there. Retransmissions are there for reliable delivery. Sequence numbers to detect losses and reorder data, because sequence numbers plays a vital role. When each packet has a sequence number automatically in destination side, it checks whether all packets are received or not, and all packets are in proper order or not. Then flow control prevent overflow of the receiver's buffer space. Means it checks the capacity of source side and destination side. Next, congestion control means adapts network congestion for greater good. Okay. Why would anyone use UDP? Final control over what data is sent and when. As soon as an application process writes into the socket, UDP will package the data and sends the packet. No delay for connection establishment, because there is no connection establishment in UDP. These are the some advantages in UDP. Single socket to receive messages, no guarantee of delivery, not necessarily in order delivery, datagram independent packets, must address each packet. This is like a postal mail. This is TCP, reliable, byte stream in order delivery, connection oriented, single socket per connection, setup connection followed by data transfer, application layer. Supports for user applications, a separate module for different applications, HTTP, SMTP, SM. Understanding TCP IP, uh, encapsulation of data uh, network, when application layer receives some message, that is original message, then it will go to next layer, that is a transport layer. Just assume that is data 3, and header 3 will be added. Then it will go to network layer. In network layer, the entire thing is data 2. Then header 2 will be added. Then it will go to next layer, data link layer, that is data 1. Then header will be added. This entire thing is called packet. Packet sent by post A, and the packet received by the intermediate routers. Then the packet received by the post B. Then the packet B is nothing but combination of header 1 and data 1. Then decapsulation of data from network delivery. Decapsulation means it takes the data one only. Here, data one will be moving to upper layer, that is network layer. It is combination of two, header 2 and data 2. Then decapsulation of decapsulation of data to the and it moves to transport layer. Then it is a combination of two parts, header 3 and data 3. Then decapsulated, then data 3 moving to miss application layer. In application layer, it is like original message. The TCP/IP protocol suite has combination of four layers: application layer, transport layer, internet layer, and a link layer. Here different layers, that is DNS, TFTP, TLS, SSL, SSL, FTP, Gopher, HTTP, IMAP, IRC, NNTP, POP3, SIP, SMTP, SMTP, SNMP, SSH, Telnet, Echo, RTP, PNRP, RLogin, ENRP. Okay, and routing protocols like BGP and RIP, which run over TCP by UDP, may also be considered part of the internet layer only. Next one, transport layers. Usually the popular one are TCP and UDP, and other protocols also there: DCCP, SCTP, IL, RUDP, RSVP, etc. Next, internet layer. IP is the popular, and ICMP, IGMP, ICMPv6, and OSPF for IP4. Next one, link. ARP, RARP, OSPF, ISIS, NDP. These are different types of protocols which belong to different layers, and this is the overview of the TCP/IP model. Application layer, application programs using the network. Transport layer, TCP, UDP. Management of end-to-end message transmission. Error detection and error correction. Next, network layer, handling of datagrams, routing and congestion. Data link layer, management of cost-effective and reliable data delivery, access to physical networks, and physical layer, that is physical layer. Uh, Anyway, thank you very much for your patience and support. Here today we have discussed about OSI reference model and a TCP/IP protocol suite, and how the data is moving from source to destination through various layers. Also, we have discussed about what are the existing protocols which belongs to different layers. Okay. Thank you very much.